Imagine a sphere. This sphere is the Earth. Now, on this sphere, this is basically a two-dimensional plane, but it's actually a sphere. So now, what we do is the next step, is to add a third dimension, which is, because of the three geographical dimensions, it's height. Now this height is not height, but we actually say that the height, each meter, is 1 second. So with every meter, you are basically above a certain point of the Earth, you are at a different part of the day, at a different time of the day. So therefore, we are able to plot all the time over a given point. Now, what this does is, imagine you want to visualize how likely it is for people to meet. And the likelihood of people meeting in real life is actually something that is very hard to imagine. But if we plot the thing as we just did, then every single second, and we just defined that every single second is a chance of meeting someone. So basically you have to be within the same cube above this point on the Earth at a certain part of the day. Another assumption obviously is that each and every person, of course, either lives the same day each and every day, or we have to add another dimension, which is basically the time over time, because currently we are only plotting a single day. Of course, you could plot all the different single days above of each other into infinity, basically. So the beginning of time would be basically 0 on the Earth, and then with every single meter we rise, we would get further along in time. The problem now is that because it's a sphere, actually it gets bigger and bigger. That's kind of a problem. So now, what is the problem here? The problem is that all these lines go into different directions. So this is kind of not very optimal, but because the Earth is the thing we are currently inhabiting, I think it kind of makes sense this way. So now, what we could also potentially do is we could take the Earth and actually plot it as a plane. And if we then now take it as a plane, then we see basically, let's just say again, the day, and we just see the day. So now, imagine you are now sitting basically on the Earth. So now, with each and every move a person makes, let's just say it's midnight, and the person is here, let's say. And then it moves up, and along this plane somehow. So now, imagine these three-dimensional lines. And these three-dimensional lines are basically our movements on the Earth over time, on a single given day. Now, given the fact that many of us have the same lines every single day on the Earth, because they move to work, not move to work, but they go to work, they come back from work, they go to the grocery store, they come back from the grocery store, they go to the post office, come back, they go to the gym, come back. So therefore all these lines are kind of similar from one day to another. So now imagine, or not imagine, but now the likelihood of somebody meeting somebody else is when a person in time, when basically two of these lines meet at the exact same cubicle. Now it is actually a cubicle and not something that looks like this into all different directions based on a sphere. So basically imagine cutting a water balloon or a basketball into different sections, but not into different, basically going right through to the middle every single cut. And this would be a section. But we imagine it as a normal plane, so therefore we have cubicles. And these cubicles measure 1 second by 1 second by 1 second, basically. Or 1 meter by 1 meter by 1 meter. Because very conveniently, the Earth is also measured in meters. So therefore we have 3 times the normal units we use for length. So now, what this allows us to do is it plots all the different parts. Not it plots all the different parts, but it plots actually our movement over time. And if now some people want to meet each other, and that's kind of a very beautiful thing actually. If you meet somebody for the first time, but you don't exchange any contact details, but you want to meet them again. Given the fact that many people move the same lines each and every day, what you could try to do is to try to meet them at the same line on another day. Not at the same line, but at a certain point. And the weird thing, for example, is that if we just assume this is the plane from here to here, and now one path goes like this, straight up here, or like this, more to the camera, then even though if from above it looks like all these people meet on a geographical area, they actually don't, because of the time difference. So therefore, we have to use the third dimension, because otherwise it all looks as if these two people are moving. If one person arrives, let's say at a grocery store, and the other person arrives also at the grocery store, but 12 hours later, then if we just look on the map, it looks as if they both met. But of course they didn't. But they only met in the third dimension, if these lines actually intersect. Of course, we have to assume that the intersection is not infinitely small, because lines are actually infinitely thin, theoretically, but actually have a certain thickness, and this thickness again is 1 second or 1 meter. And that's, I think, a very nice model. And now, if you want to meet a person again, you met once, and this happened to me basically today. I spoke to a person randomly I met someone randomly, and now I didn't exchange any contact details. But the question now is, how can I meet this person again? And given the fact that many people have habits, many people have kind of the same routes, then the likelihood of you meeting this person again would probably be the highest if you go to the exact same place on another week, because most of us have kind of a weekly ritual. So therefore, the person I met was basically went out for a walk, and I was biking, basically. And now if I bike at the exact same time, on the exact same day, not the exact same, but on the next weekday in the next week, not the next weekday, but in the next week on the same weekday, then I think the likelihood of these lines intersecting is the highest. And therefore, the likelihood of meeting any person you want to meet again, where you have no contact details whatsoever, is higher. But if you want to think over time, for example, Einstein, for example, or any person in history moved basically on the same grid, on the same Earth. So the only thing that separates us from these people, from all of these people, from above, it looks as if these people all kind of met, but of course they didn't, because of time. And because time is kind of very, very big with these billions of years. This means that they're all basically going from the Earth. You could imagine also from maybe other planets that actually have life. You could imagine, now if we imagine a sphere again, or if we just imagine my head is the Earth. So now I have these antennas going out, and these antennas represent time. In the middle of the Earth there is time zero. Of course not exactly, but we actually assume the outer Earth as time zero. And then as time moves on, all these lines go just to infinity in time. And that's just a very nice image. Also, if you think about the fact that on other planets there are also these antennas going out, maybe of life on this planet. And that's how to visualize how we move over time.